On cars.
I had no door locks.
Okay, 1.5 we're looking at today. 1.5 is just so kind of a short lesson. There's not a ton of stuff going on. It's just kind of talking about another area of limits. We're talking about infinite limits. So we're going to kind of put kind of everything we've kind of done together to look kind of at infinite limits. So it's kind of a lot of stuff kind of put together. So it's just kind of looking at more limit stuff. So infinite limits, if I look at the definition of an infinite limit, let me get that real quick. So an infinite limit is we're looking at as x is approaching some number, y is approaching infinity. So that's what I mean when I'm saying an infinite limit. And we kind of already talked about it a little bit, but we weren't able to actually say it's approaching infinity. But now we'll be able to kind of introduce some stuff. So as I'm approaching some x value, the y value will be approaching infinity. So as I look at example 1, I want to use the graph to determine whether f of x approaches infinity or negative infinity as x approaches negative 2 from the left and from the right. So if I actually wrote it out like this, it would be written out, the limit as x approaches negative 2, let's go do negative 2 from the left, of f of x, and I want to know what that approaches. So just writing it out from the words they tell you. So I literally want to know what is my limit as x approaches negative 2 from the left of my function. And my function is just the graph. So as I look at this, as I'm approaching negative 2 from the left, I want to know what are my y values approaching. So as I'm approaching negative 2 from the left, my y values are approaching negative infinity. Now just be careful with what negative infinity means. Negative infinity doesn't mean smaller and smaller numbers necessarily. It's saying that we're getting bigger and bigger negative numbers, which would be smaller numbers, but it's easier if you think about it as this is going down, so I'm getting bigger and bigger negative numbers. So I'm approaching negative infinity. Now as I approach x from negative 2 from the right, so the limit as x approaches negative 2 from the right, so I approach from the right, my y values are going to positive infinity. So bigger and bigger positive numbers because it keeps on going up. So kind of the same idea, but now we're looking at as I approach an asymptote, maybe necessarily, what does my y value approach? Now, just kind of note on this, we have to be approaching from the left and the right individually. If I would say what is my limit as x approaches negative 2, and I wouldn't specify from the left or the right, it would not exist because it would be approaching two different things. So just kind of a side note, on this one you had to make sure they identified left and right because otherwise it would be two separate ones. Okay? Vertical asymptote. So vertical asymptote, if f of x, so kind of looking at what we just did, if f of x approaches infinity or negative infinity, so if f of x approaches infinity or negative infinity as x approaches c. So like I said kind of yesterday, I want to get you used to being able to read these definitions. I don't expect you to be perfect at them, but at least try to start to be able to decipher them. So if my function, which basically means the graph, so if my graph approaches infinity or negative infinity as x approaches some number c, which is what we just talked about in the example above it, from the right or the left, then x equals c is a vertical asymptote. So we're just putting into words what we just talked about with the example. So as I'm approaching from the left to right some x value, and I'm approaching infinity or negative infinity, that means that the y values get bigger negatives or bigger positives, I have to have a vertical asymptote at x equals that number, at the line x equals that number. Because to approach infinity or negative infinity, an asymptote means it's going to get bigger, or smaller. Okay? So, let's go ahead and look at example 2. I want to find the vertical asymptotes, if any, of the graphs of the functions. So kind of like we talked about when we talked about domain and range, or domain, it's the same idea. Vertical asymptotes are going to tell me where I have my negative infinity limits. So as I look at example 2, so it's kind of a review, but that's okay. Find the vertical asymptotes, if any, of the graph of the function. So as I look at this, I have a rational function. So I know my vertical asymptote will be where the denominator is going to give me 0. So as I look at this, what values, will there be any x values that if I plug in will give me a 0 in the denominator? No. Even though it's x squared plus 9, there is no way I can square a number and get a negative 9. Even if I do negative 3, it'll still give me positive 9. So there's no vertical asymptote. Because the denominator can never be 0. Okay? So kind of review from what we did. Okay. Any questions on that? Okay. Let's go ahead and look at B. Same sort of idea. We look at this, I have a rational function, so I want to see, okay, where does my denominator give me 0? First thought on this. Factor. So we have x squared plus x minus 2 will factor to x plus 2, x minus 1. So factoring allows me to see more specifically what x values will work or not. So x cannot be negative 2 or 1. So I will have vertical asymptotes at negative 2 and 1. Now, if we kind of think about this, we can kind of think about with the definition of limit. So as I think about 1, let's look at 1 real quick. Let's look at the limit. The limit as x approaches 1 from the left. Let's just kind of look at this and see if we can get this. So what this said is this says that we should have, if 1 is indeed a vertical asymptote, I should be approaching negative infinity or infinity. As x approaches 1 from the left of this function, I should be approaching infinity or negative infinity. So let's just try it real quick and think about it. So as I approach 1 from the left, and you can either use the factored form or the non-factored form, my top is going to stay 3. On the bottom, as I approach 1 from the left, so if we kind of think about plugging in numbers, if I plug in I don't know, negative 2, I get a 0. If I plug in a 0, I get a negative 2. If I plug in I don't know, a half, so I go from 0 to negative 2. If I plug in a half real quick, this is 2.5 times what? Negative a half. So what's 2.5 times negative a half? I don't know off the top of my head. Someone do it real quick on your calculator. 2.5 times negative a half. Negative what? Negative 1 and 1/4. So I go from 0 to negative 2 to negative 1 and 1/4. If I plugged in, I don't know, 1 from the left, 0.25, you'll notice that we're going to be going to smaller numbers on the bottom. So I'm going to be approaching smaller numbers on the bottom. Does that kind of make sense what I did there? So I'm going to be approaching negative smaller numbers on the bottom. So as I think about this, I'm going to have 3 over This is just going to stay a constant over here. And I'm approaching smaller and smaller numbers on the bottom. Now, what is happening to this entire thing? I know it's a negative. What is happening to this entire thing, a fraction, if I get smaller and smaller numbers on the bottom? It gets bigger. That's kind of a key thing as we deal with these. So as I get smaller and smaller numbers on the bottom, my fraction will get bigger and bigger. Think about if I do 1 divided by 2 is a half, 1 divided by 1 is 1, 1 divided by a half is 2, 1 divided by a fourth is 4. So my whole thing is going to be getting bigger and bigger and approaching negative infinity. So as we think about this, it's kind of helpful to kind of be plugging in numbers as I approach one from the left to kind of see, okay, what does this whole thing look like it is approaching? Now if I try it from the right, we can just do that real quick. If I try it from the right, let's kind of think about from the right what I have. It should be a little easier. So I have a 3 on top. As I approach 1 from the right, let's plug in 5. Let's just see what happens. If I plug in 5, I get a what in the denominator? 7, 28. So I get 28. If I plug in 4, 18. If I plug in, let's see, 3, 10. Plug in 2, 2, 4, 4. So what is happening on the bottom as I approach 1 from the right? So I plugged in 5, 4, 3, 2. My bottom is getting smaller and smaller. So if the top is staying a constant number and my bottom is getting smaller and smaller, the whole fraction is getting bigger and bigger. And there's no negatives here, so it's positive infinity. So as you kind of look at that, vertical asymptotes have to have this characteristic. From the left, as I approach 1, now we could have done this with a -2 too, it'd be the same thing. But as I approach a negative or an asymptote, a vertical asymptote from the left and the right, I should notice is either going to be getting to negative. I don't have it up real quick.
You will notice that we would have a vertical asymptote and I would be approaching negative infinity and positive infinity. Okay? So you can always kind of look at the graph. I want to graph this real quick to make sure I did it right. So let me get on Desmos. If you don't have the Desmos app downloaded on your phone, it's helpful. I like Desmos better than Graphing Calculator. It's just Desmos. It's free. So if I graph this real quick on Desmos, I hope this is the same graph. So let's see, 1 divided by, or 3 over x squared plus x. Okay, so as I look at the graph of this, we said, okay, here's my at 1. So here's my vertical asymptote. I had 2, -2, and at 1 vertical asymptote here. I said as x was approaching 1 from the left, I was approaching negative infinity, which makes sense with the graph. And as I'm approaching 1 from the right, I was approaching positive infinity, which it does. So you can always go back to the graph and kind of, so if you're confused, you can always kind of convert back to the graph and say, does this kind of make sense? Okay? Any questions on that part? So vertical asymptotes, they're kind of easy to kind of see it just by looking where the bottom is 0, but they should always hold that characteristic. They should always approach negative infinity or infinity. Okay, let's go ahead and look at example 3. Like I said, I don't have a ton of notes to take today. Example 3, determine whether the graph of the function has a vertical asymptote or a removable discontinuity. Graph the function using a graphing utility to confirm your answer, just like we just did. So as I look at this, we look at the first one. And we have f of x equals x squared plus 1 over x plus 1. This is a rational function.
So just by looking at it, if I had to guess, I would guess my vertical asymptote would be where? Yes. I would guess my vertical asymptote at x equals -1. Just like we've already kind of talked about with the domain, same idea, where we know x cannot be -1, so I'm assuming there's a vertical asymptote there. Okay? Now let's go ahead and check this using kind of the definition limit stuff that we've already talked about. So as I approach -1 from the left of my function, for it to truly be a vertical asymptote, I have to either approach -infinity or infinity when I do from the left and right. So let's check this. Now, like I said, this is kind of a thinking. There's no good like step-by-step way. You just kind of have to plug in points and kind of think about it. So as I approach -1 from the left, let's start with -5. Let's just plug in a -5. So if I plugged in a -5 here, I would get a 26 over -4, so negative, I don't know, I'll just reduce it, negative 6.5, is that right? Yeah, so I'll just reduce it so it's easy into a mixed number so it's easier to kind of see them. Okay, I plugged in a -5, let's plug in a -4. If I plug in a -4, I'm approaching -1 from the left, so -4 will give me 17 over -3, so that will be -5 2/3. As I approach, let's see, as I plug in a -3, that will give me 10 over -2, so -5. As I approach -2, I have 5 over -1. Is that right? -2? -2. Yeah, so I also get -5. So as I look at this, this looks like my y values are approaching what? Let's see. Let me look at that. Let's try it from the right and see what I get. I'll look at that real quick. Let's try it from the right and see what I get. So as I try it from the right, let's start with, I don't know, we can start with 4. If I plug in 4, I get 4. So 17 over 5. So 3 2/5. As I plug in 3, I get 10 over 4. So 2.5. As I plug in 2, I get 5 over 3. So 1 2/3. As I plug in 0, I get 1. I get 1. And that's good enough. I can kind of see a pattern. So as I look at this, let me get the book real quick. See how they explain it. So as I look at this, you kind of see that I'm approaching something. Oh, did I write this down wrong? Just a second. Let me look. Just a second. confused because I don't, it's not necessarily approaching infinity. So as I approach, the graph is, yeah, so if I look at a graph, it's approaching infinity. Did I get these, are these points?
The points are right, you just need to keep going. Because like it goes up and then
It drops.
It does drop?
Yeah.
Okay.
It comes in. and straight drop.
Okay, got it. So this is what the graph looks like real quick. This is why. So as I'm, okay, because it looks like it's approaching 0. So this is why I'm confused. So if you look at the graph here, it goes up. So that's why, okay, as I plugged in a negative, as I'm approaching from the left, it looked like I was approaching 0. That's why I was confused. But then it drops down. So if I would have plugged in more numbers, I would see it's approaching infinity or negative infinity. So if you need to plug it in to your to graph it, you can to see that. But like I said, because I knew it had to be approaching infinity or negative infinity, to me it looked like it was approaching 0 when I plugged in numbers. So if this would happen, just like here, graph this and kind of see what it looks like it's doing. If you're not seeing it's approaching negative infinity or infinity. Okay, questions on that one? Sorry, I was confused a little bit. Okay, let's look at B. If I look at B, I have a rational function. First thought on this would be, yeah, let's check for vertical asymptotes. Before I do that, factor everything and see if some things will cancel. So the top will factor to what? X plus 4, x minus 2. Yeah, you're good. X plus 4, x minus 2. And the bottom will factor 2. Yeah, x minus 2, x plus 2. And I notice right off the bat this will cancel. The x minus 2's will cancel, which is fine, but be careful. If the x minus 2's cancel, now you probably didn't do this a ton in pre-calc, but anytime you factor and something cancels, that means that I'm going to have a hole there. So I will have a hole at, I don't know why I'm using cursive for right now. You will have a hole at x equals 2. So this is another time where you, piecewise functions, you may get holes. Also, if you have something like this, a rational function where things cancel, that is where you have a hole at. So you would have a hole at x equals 2. Same thing with my vertical asymptote. I would have a vertical asymptote at x equals negative 2. And if you graph this on Desmos, let me just get my iPad and graph this real quick. If you graph this, you will literally see that I will have a hole at x equals negative 2. Where's my Desmos? There it is. Okay, so if I graph this, it also has an iPad app too. I don't want to sign into my iCloud. Okay. So if I graph this, maybe it's going to be slow. So if you don't have the app, I would download it because it will save you a lot of time. Maybe. Maybe. Do you have it pulled up?
Yeah. You have to click on the two that were to.
Okay. Yeah, if you look at this, this is what the graph looks like. Let's do it. Nope. Okay. So if you look at this, and do you zoom up? Does it see it? It should just show up.
Then click and drag over to two.
Oh, yeah, okay. So if you click and drag over to 2, you can see that it's undefined at 2. It's hard to tell now, but yes. It is, there will be a hole there if it doesn't show up. Okay. So that is another way, and this is, if you have a hole, this is your removable discontinuity like we talked about yesterday. So anytime you have a hole, that's considered a removable discontinuity. Okay. Any questions on that? Okay, example 4. We're looking, I want to find each limit. So as I look at this, I'm looking at this, and just by looking at these limits, I'm thinking, and the function, I'm thinking I'm going to have a vertical asymptote where? 1. So just by looking at this, I'm thinking I'm going to have a vertical asymptote at 1. So as I'm approaching 1 from the left and the right, I should be seeing that I have infinity or negative infinity. That's what I'm thinking. So as I look at this, let's go ahead. I'm approaching 1 from the left. So I like just plugging in numbers and seeing if I can see it from plugging in numbers. So as I approach 1 from the left, this is another way to kind of deal with limits. If I try to plug 1 in, I'm going to get a 0 in the denominator. If I try to factor the top, nothing's going to cancel out with the x minus 1. You could graph this and look at this, but let's just kind of think about it intuitively. So 1 from the left. So let's plug in negative 3. So if I plug in a negative 3, that's going to give me back what on top? 18. Yeah, 18 over negative 4 or negative 4.5. So I'm literally just kind of plugging in points as I approach 1 from the left. So now let's plug in negative 2. So if I plug in negative 2, that will give me back 4 plus 6. So 10 over negative 3 or negative 3 1/3. If I plug in a negative 1, that will give me back 4 over negative 2 or negative 2. As I plug in 0, that will give me 0. As I plug in that's good enough for now. Let's go ahead. So as I look at it, I'm thinking, okay, once again, it's not necessarily approaching infinity. It looks like it's more approaching 0, is what, just by plugging in points, it looks like. If I try to plug in, let's do 1 from the right here. So if I plug in 1 from the right, we have, let's try, whatever, 3. If I plug in, or we'll try 4. If I plug in 4, we're going to have 16 minus 12, 4 over 3, so 4 thirds, so 1 1/3. 3 will give me 18 again. No, not 18. 0. 2 will give me negative 2 over 1. So negative 2. So as I look at this, so this is kind of the first thing I always check. I always just check this and see, okay, does this show that I'm going to infinity or negative infinity? Okay, if that doesn't show it, I don't know why this is being really slow. Just wanna graph on here. So if that doesn't necessarily show infinity or negative infinity, because this is going to 0, because negative infinity literally means I'm getting bigger and bigger negative numbers. So my negative numbers are getting larger and larger. So if I graph this real quick, so if it doesn't necessarily show negative infinity or infinity by plugging in points, graph it. Kind of like maybe the one we just did. So let's do x squared minus 3x divided by x minus 1 squared. Let me get something real quick to help with the quick. I'll find it later. So as I look at that, we have this graph. So by looking at it, as x approaches 1, so I do have that glare is really annoying. Let me just do that. I do have as x approaches 1, I do have a vertical asymptote. So as I look at this, as I'm approaching 1 from the left, it looks like my y values are getting closer and closer to 0. Okay, if I would have went further, I would have noticed that if I would have plugged in like fractions between 0 and 1, I would have noticed my y values kept getting higher and higher. So I would have noticed that my y values are going to infinity. Same thing as I was approaching 1 from the right. Okay, I noticed that my values are going to be getting smaller and smaller. If I would have kept on going, they would have gotten smaller and smaller. So I'd have been approaching negative infinity. So sometimes it's helpful to plug in things. Sometimes you can see it by just plugging stuff in. Sometimes you kind of need to resort to a graph to kind of look at it. So as x goes to 1 from the left, I'm approaching positive infinity. And from the right, I'm approaching negative infinity. So it's kind of working with graphs, working with how do I figure out infinity, negative infinity by just plugging in points as they approach it. A couple things to kind of look at. Okay, any questions so far? Okay. Properties of... it's almost in 30. Okay, properties of infinite limits. I'm not going to worry too much about these because they kind of follow the same properties. Let's look at example 5. Find the one-sided limit if it exists. So as I look at this, the limit as x approaches negative 3 from the left. First thing I noticed, let's factor the bottom. See what that looks like. So that'll be x plus 3x minus 2. So as I look at this, I notice I am going to have a what? A hole. The x plus 3's will cancel. So I'm going to have a hole at negative 3. So if I have a hole at negative 3, doesn't necessarily mean that I have to be approaching infinity or negative infinity. No, that only works with an asymptote. So since I have a hole at negative 3, I'm thinking, well, I'm probably just approaching some number. Because if I think about a graph of this, whatever it may be, if I have a hole at, let's say here's negative 3, if I have a hole at negative 3, that literally means I'm going to have a hole. So my function is going to keep on going like normal. I just have a hole. So I still will probably be approaching an actual number. So my function looks like this, 1 over x minus 2 after I cancel them out. Just like we did yesterday. Plug in a negative 3. So 1 over negative 5. So negative 1/5 is my limit. So just be careful. Even if I have a hole there, it doesn't have to necessarily approach negative infinity or infinity. That's only if I have an asymptote. Okay, let's go ahead and look at B real quick. I want to know the limit as x approaches 0 from the right of 2 over sine 0. So as I look at this, my first thought is if I try to plug in 0, what is sine of 0? 0. So I can't just plug in 0 because I'll get a 0 in the denominator. So let's just kind of think about this. Let's just start plugging it in. Let's plug in values. As I get closer and closer to 0, have your calculator ready. As I approach 0 from the right, let's just see what I get. So let's try, I don't know, plug in 5. So do 2 divided by sine of 5. And you would probably just assume you're going to be in radians unless they give you the degree symbol. And what's the decimal?
Negative 2.1.
Negative what? 2.1? Are we all kind of agree with that? Okay. Next one, let's plug in a 4. So I'm literally just plugging in points as I approach 0 from the right. If I plug in a 4, 2 divided by sine 4, do you get 2.6? Is it negative or positive? Negative? Okay. So as I approach 3, 2 divided by sine 3. What is it? 14.1. Okay, we agree with that? Okay, let's try 2. See if I notice anything. 2.19, whatever. You round to, I don't really care. So I plug in 1. I get, what is it? 2.4. Okay. So as I look at this, do I see, I don't know if we did anything wrong necessarily. Do I see any pattern in doing this? Do it? Yeah, there's not really any pattern here. I don't see necessarily. So let's think about, okay, so that's kind of one way, and that didn't really help me find anything. So let's think about this. Let's think about just my bottom. If I think about the denominator, sine of x, because it's easy for me to just kind of think about sine of x. So if plugging in numbers doesn't really get you anywhere, kind of maybe just look at the denominator, sine of x. So if I think of the sine of x graph and it doesn't really surprise me that it oscillates because sine goes up and down. So I'm not really too surprised that it goes up and down. As my sine graph is approaching 0 from the right, what is my y value doing? So as I approach, I'm only worried about the sine. As I'm approaching x value 0 from the right, my y values are getting smaller. So if my denominator is getting smaller and my numerator is a constant, what was my entire fraction going to? It's getting bigger. So it's going to infinity. And it is positive or negative infinity. My 2 is positive, and my y values as I go from the right are still positive because they're above the axis. So it should be going to infinity. If you're ever not sure, well, let me graph this. I forget if they do signs on here. Let's do, let's do 2 divided by sine of x. So as I look at this, here's my graph. 2 divided by sine x. So as x is approaching 0 from the right, my y value keeps going up. So my y value approaches infinity. Okay? Any questions on that? So it's just kind of a mixture of talking about vertical asymptote. Some of it's review, some of it's more conceptual, this lesson is, than maybe straightforward, as maybe some of the other lessons have been, which could be nice, could not be, just kind of depends. Okay? So there's that. You have some time to still have questions on 1-4.